Okay, my friends, as you know, I incorporate a lot of things with a lot of other things. Well, what does the most powerful nuclear bomb have to do with Schumann resonance frequencies and free energy? Well, let's look at the nuclear bomb detonated 1961, the biggest ever. This is what humanity has come to develop something like this. Now it's 57 million tons of TNT. I don't think it's 57 million tons, but it might be. Now, this is the nuclear blast. Boom. Now, I am going to slow this down to half speed so we can watch it a little better. Here goes. Now, there is the original explosion. What do we see? Nothing but whiteness. Nothing but whiteness. And then it will expand. Now, remember, I told you anytime you see whiteness, that means impact. That means pressure. Now watch what you're going to see. You're going to see the actual Schumann resonance frequencies exactly certain distances apart, and it equates to 6.5 hertz distances between each one of these, and that equates to the difference between the potentials related to the speed of the spin of the Earth and the particles in space. Watch up that. You see that? Boom, boom. What is that? That's 6.5 hertz distance. And there's, the first one, I don't know what it is. It starts at like 7 point something, but then they go 6.5 above each one of those. You see that? That's literally a layer. The one up above is a layer. And why are you seeing a donut here? Well, this is forcing outwards. We don't see the impact out here yet. To my way of thinking, these are the dark particles. Something's hitting this out here. And we're seeing nothing but whiteness here. So I think these are the dark particles. Very rare that they would ever have any interaction, but with this kind of violence, even the dark particles are interacting. That's my take. You see it? Unbelievable. Loud. Now, obviously everything's shaking. It blew out windows in Finland. It reverberated around the Earth 3 times. The whole Earth atmosphere shook. Now this is the difference. So this layer is scrubbing through the atmosphere. This layer is scrubbing through the atmosphere. Another layer out above is scrubbing through the atmosphere. Each one of these layers is literally one of these rings. So what happens? Here's the deal. In the space around Earth, everywhere, there's a ton of extra electrons. When you push on them, they glow. That's what light is. It's energy. Now, so here's the Earth spinning. Spin, 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 spin. Well, what's in the outside ring of the Earth's atmosphere? Particles. What do? They rub against these other particles. All right. Now, those other particles force the particles that they're rubbing into to come inward and send their energy inward. Now, don't forget, only the white energy travels that I know of, that I see. The white energy pushes. The black energy, I've never seen push anything, although that might be the black energy pushing in this particular case, which is so extraordinary. But anyway, normally what you're going to get a resonance frequency, push, 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 right down to the Earth. So a setup, a setup, a setup, a setup. The power, non-power, power, non-power, power, non-power. Power all the way around the Earth. All the way around the Earth is the power particles. Because they always want to be apart from each other. The mass of the Earth is dark energy. And I believe the dark energy is the gravity. I mean, there's a certain percentage that apparently they're not equal. The dark and the power energies are not equal. That's what they're finding out. That's why they walked away from the Bohr model, because it doesn't equal. There's no conservation of energy, or whatever they want to call it. In the electron flood theory, it works very well. And it might be related to how much push there is to shove, how much dark energy accumulates in here. If it spins real fast, maybe more dark energy would accumulate in there, because there's so much rub on the outside, it pushes the dark energy in. So you get a ton of extra power or extra attraction, because I think the black is the attractor. I think the black is literally gravity, graviton. It's a puller. It pulls in the white, and that's all it does. It doesn't have an explosive value, but it pulls in the white. That's what I'm seeing, and this to me explains the Schumann resonance. So here's what happens. The Earth spins through the ether. Spin. Only the whites push the other whites. All right, so the whites push the other whites, but the blacks want to be against the whites, so they're going to be just lining up with them. So it pushes the whites, and then the blacks stay with them. Pushes more whites, and the blacks stay with them. So this sets up the layers at 6.5 hertz apart, because it's going to push just the same amount here as it does there, and it does there, and it does there. And then the Tsar bomb shows the layers. So that's the Schumann resonance. Now, can we tap into that? Because from every one of these layers, we're creating lightning. It's not really lightning. We're creating extra electricity. It's just got to go somewhere, and it goes in the form of lightning. That's the extra electricity. It's generating it all day long as we spin through the atmosphere. It's identical. Hold on. Identical to what we are doing here in the generator. Spinning like this. It's just automatically spinning. Nobody's running electricity into it. But when you do that, you create electricity if you are spinning through a magnetic field, which is the magnets in the motor. In us, the magnetic field is the ether that surrounds us. So we are continuously generating electricity all day long, 24 hours a day, 7 days a week. Anytime electrons hit other electrons, and that is all day, 24 hours a day. So there's a ton of extra electricity in our atmosphere coming down as lightning, all kinds of electronic discharge, heat, all of those things. There should be a way to tap into that. Now, I know that NASA did a tether experiment, which went terribly awry. But I know there's a way to tap into this extra push of electrons that eventually end up hitting the Earth anyway. That's where they're going to go eventually, because it's push. And eventually it gets to the Earth. The Earth is growing. The Earth is adding electrons all day long, every day. Because the electrons coming from outer space are coming in. We're not bleeding them back into space. They're pushing in. So don't get into the, oh, there's a helium, hydrogen just goes floating off. No, it doesn't. It's being compacted into our atmosphere. Anytime you compact something, you cause heat. Anytime. I don't care what you say. You compact it, you're going to have heat. Simple as that. All right, this is what they call the Earth's heartbeat, and it's ba-boom, 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 ba-boom. 6.5 approximately hertz in between each one of these ba-booms. What is that? Push to shove, push to shove, push to shove. Push to shove, push to shove, push to shove, push to shove. All the way down till it hits the Earth. Now, if you had too many electrons in here, they may not come down to Earth. They may try to go back up. And that's what's happening with these sprites and these ELVES. And they are fairly new phenomena. Okay, I'm not going to bore you with the details, but what I did show you, these are the resonance frequencies. And this is the reason they're set up. It's push to shove. And so it sets up regions 6.5 hertz apart until it gets down to the Earth. And they are saturated with electricity, way too much at this moment, because we have overcharged the Earth. So what does that mean, Roger? Well, here's what it means. More recently, This is newer research, or it's just something new that's happening. I believe it's something new that's happening. Discrete Schumann resonance excitations. Certain areas of excitation, which means they're getting really, really pushed, and something's really, really pushing back, so it's becoming very, very excited. They're linked to transient luminous events. What are transient? First of all, it comes and goes, and not every day it's doing the same thing. Second, luminous means it glows. Events. What are they called? Sprites, ELVES, jets. You ever hear these things before? In talking about, they teach you about that in school? No. This is all new stuff. Other upper atmosphere lightning. What is lightning? We know what lightning is. Lightning is electrons. It's literally electrons. It's not photons. Photons are light. Lightning is a particle that wants to be with another particle to create a photon. But in order to do it, it has to invade something, and it does. And that creates extremely explosive invasion. That's lightning, static electricity, electric wires, goes right to ground. It wants to be in the ground because the ground wants to accept these. The ground is the black part. This explosive part is what's coming to the ground. All right, I've shown it many times, so I'm not going to dwell on that. Now, this is a new field of interest using Schumann resonances, is related to short-term earthquake predictions. Say, wow, that's very interesting. Schumann resonance and earthquake prediction. Well, why would this Schumann resonance? These are just frequencies of light pushing back. Push to push to push to push. Well, guess what? They are so powerful, we have no clue. There's so much power now in these frequencies of push to shove, it's literally doing this to the Earth. So the Earth, hold on, I gotta get this discombobulator from all my other magnets. Some of these neodymium ones, man, they can really do some holding. All right, anyway, here's your Earth. All right. It's a ball, literally a part of this. And it is, that's all it is. Now, it's in molecules, and those molecules are fairly stable, and we're spinning in space. However, the space we're spinning in is not just a static, it stays the same. We may hit a hard hit, because this is nothing more than our stuff that's out here, our atmosphere. Push, 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 push. Well, sometimes it's a nice easy flow pushing, and sometimes somebody really pushing back hard, and that's when we get these spikes in the frequency, and then we get the ELVES and the lightning, and we get the sprites and the jets and all these upper atmosphere interactions that are extremely violent and energetic, and let's go look at those. Alright, I told you this was going to be fun, and this is fun. This goes back to July '94. This is the first color image of a sprite, and you say, wow, that is amazing. What are we seeing? Well, we're seeing, and I'm going to show you in much better detail, but this is the first one I've ever seen. And we're seeing them in multiple spots across, and they do that regularly. Now, what is happening here? I will show you later. This is sending electricity up instead of down. Usually lightning goes down to Earth. This is sending them up, and they're red. They are not like, we'll talk about the reason they're red and the reason they're going up instead of down and so forth in the other pictures. But this is up in Alaska. Now, when you see the aurora borealis, the different colored lights coming down, the reason you're seeing different colors of vapor in different regions is because the magnetic flux lines are coming up and pushing back at them. So it pushes harder at the red than it at the red, let's say, than it does at the blue. So you stripe it out, it gets red and then yellow and then green and then blue and so forth. That's why you see them waving like that. The wave is the actual Earth crushing through the particles. That's what's creating a wave. And we see it in Aurora Borealis. Now this doesn't get any better than this. Now, what are we seeing? Sprites. Now, what's happened here? What's happened here? Let's go back to the book. Don't forget, get your book and start writing notes. Don't just try to remember this. I mean, you're probably going to remember it fine, but it's not going to help you to present it to somebody. I can present this and say, I know what's happening here. What's happening is each one of these layers, or in this particular case, a certain layer has become so overcharged in between these layers, because this is a layer, this is a layer, this is a layer, same thing here, here, here. This layer right here, this exact layer, they tried to shoot electrons up from this layer down below. So this layer, just like we're here, okay? This layer down here shooting up, bam, it hits this layer, which is the pushback, and the pushback says, oh no you don't, and you get this big upward impact zone, and it says, get the hell back, I have too many already up here, I don't want you here, go away. It absorbs some, you can see some of them are up in here, absorbed, and then these get forced back in these little trickles back into their own region that they came from. We're too overcharged. The Earth is literally overcharged. As we spin, we keep crushing more and more and more and more electrons in. And they don't just spit back out into space. It just doesn't happen. We give off some luminosity, yes. Those are particles, yes. Do we give off a lot of gases and helium and hydrogen and so forth? No. We give off luminous energy. Now, if we could beam energy out of our region and just beam it out into space, well, maybe that could cool down the Earth. But I don't think you could beam enough out from what's coming in. The sun is pretty powerful, and that is giving us all the energy. And as we spin through the ether and crush into it, it pushes the particles in. They just push in, they push in, they push in, they push in. Not much you can do about it. So there's some things, but you saw the Tsar bomb, you saw the layers set up, you saw the whites only push whites. I've shown that in that Schlieren. You got to go back and do some investigating of the videos I've been showing about this. I should put it together in some coherent format so that it makes a little more sense to the average person. I'm sort of a hit and miss guy. I get caught up in the moment. That's just the way I do things, and I think for me it's worked very well. Do what you think is the best. You know, like I said the other day, I just hate going back and editing. So, oh, should I have said that? Oh, I shouldn't have said that. And let me take this out. Nope, not going to happen. I bump here and there. But the takeaway here is you got the layer here. It says, I got too many electrons here. Send them up. They say, boom. It's no. You get back. So you got the sparks coming up and pushing in as much as it can accept. And then they trickle back down. It just says, I can't take anymore. So you know what's going on here. There's a bounce. There's a bounce. We have too many electrons, and this may have hit a real dense region that just impacted this particular frequency. Now, I don't know. I would assume it's going to be on the furthest out one. It would have to be the impact zone. And then it would push them all down like that. And some of them might be a little more overcharged than the other ones. And the ones that are would just explode and squirt, basically, like that's doing. All right, here's the key. As I say, we're spinning and we're also being ripped through the Milky Way. And we're also spinning around the sun. I mean, we got all kinds of mechanical forces going on against our particles, which are the other particles scrubbing, causing these resonance frequencies. Now listen to this, which is nothing more than heat and a buildup of electrons, because it all relates to lightning. Here it is right here. Observations of Schumann resonances have been used to track global lightning activity. The more lightning, the more scrub. The more scrub, the more electrons. The more electrons, the more interaction. And we are overcharged, so we don't want to accept a bunch of electrons and have them flow to Earth anymore. The Earth says, I'm overheated, man. You just stay the hell out of here. Too much already. So then we get in these sprites and ELVES and all that business, and global warming. All of the ice is melting. Anyway, so let's get back to this. Observations of the Schumann resonances have been used to track global lightning. That's global electricity, global electrons. Owing to the connection between lightning activity and the Earth's climate, which is always, the more lightning you have, the more interaction between the atmosphere. It has been suggested that they may also be used to monitor global temperatures. Yes, obviously, the more of these, which is the more of the Schumann, the more temperature you're going to have. All right? So they can monitor the global temperature variations using Schumann and variations of water vapor in the upper troposphere. It has been speculated that extraterrestrial lightning, that's on other planets, somewhere outside of our planet, not on us, may also be detected and studied by means of their Schumann resonance signatures. Schumann resonance, as I said, is the only reason it's happening is the spin of our particles against the particles that are in space that are impacting us. The faster we whip around the solar system, the more impact we have. The faster we spin on our axis, the more impact we have. The particles we're ripping through in the Milky Way, in the galaxy, on the arm of the Milky Way, the more impact we have. The more the sun reacts and gets active in its solar cycles, every year, 11-year solar cycle, highs and lows, the more particles it sends out, the more we react to these. Now, and these are the global lightning. So they've been used to track global lightning. Owing to the connection between lightning activity and the Earth's climate, okay, more of these makes more climate change. It's been suggested that they may also be used to monitor global temperatures, obviously, and variations of water vapor in the troposphere. It's always related to heat. Has been speculated that extraterrestrial lightning on other planets may also be detected and studied by means of this Schumann resonance signature. And again, the speed of the planet spinning and all those other variations. Schumann resonances have been used to study the lower ionosphere on Earth, and it has been suggested as one way to explore the lower ionosphere on celestial bodies. Let's just stay on Earth. What is our lower ionosphere? That's where the scrub of the particles in the lowest regions of around our globe, as it scrubs and spins against the other particles, that creates a zone, as I showed you in the Tsar bomb. You're going to have these zones. So they may be talking about that zone right there, the lowest zone. All right, so more recently, discrete Schumann resonance excitations have been linked to transient luminous events. They're seeing all these sprites, ELVES, jets, just like I was just talking about. And also extreme upper atmospheric lightning, which is a collection of particles that does not want to be there. We have too many particles already. The Earth is pushing back now. It's a new field of interest using Schumann resonance related to short-term earthquake predictions. And again, we're nothing more than particles being crushed, and they can crush like that. I mean, they're obviously not going to do that, but they can jiggle a little bit, and then you get earthquakes. Just what's going on. So that's a new field of studies. And interest in Schumann resonance was renewed in 1993 when E.R. Williams showed a correlation between the resonance frequency and tropical air temperature, suggesting the resonance could be used to monitor global warming. Well, it is global warming. The Schumann resonance, if it changes, it increases the pushback, that's more and more temperature. That's global warming. So if we monitor the Schumann resonance very carefully, we can tell where it's warming and how much it's warming. And I can tell you where it is warming just by what's going to happen. It's interaction between molecules to molecules, particles to particles. Mountains are going to have a lot of interaction. That's why you get that cloud activity right up at the mountains. There's slamming particles into other particles. And that's just what's going to happen. You're going to have a lot of electron interactivity and a lot of boiling, really, of the atmosphere. It's exactly what it is. It's push to shove. They say, I don't want you in here. We have too many already. I told the guys down there to take them. They said they were already filled up. What do we do? Push them back up there. You say, well, what do we use? Throw a sprite up there. All right. Don't want them, pal. What are we going to do with them? Push them into the buildings. Push them into the ice. Push them into the tundra. Push them into the water. Push them into the people. Heat up the atmosphere. I don't care what you do with them. Just don't bring them back up here. And I got more coming. And I know what they're doing. They're burning all kind of things down. They're adding to them, but I can't do anything about it. I'm sorry. They're on the way. Have a nice day. Fios con Dios. Okay, my friends. This is something I drew a while back, a little doodle. There's the sun. Now, you see all these little loops and stuff when you see solar flares and things. The surface of the sun is only 6,000 degrees. 6,000 degrees. Way out here where the solar corona is, which is the outer atmosphere of the sun, it's millions of degrees. How did it get from 6,000 to millions? It's scrubbing and spinning and tearing through the particles it has to force its way through, creating enormous interactions and spitting out particles energetically, which we call sunlight. Right? And they can burn you, and they can warm you, and they can interact in the atmosphere, and they can create lightning. They can do all kinds of things. Now, what do they really look like? They look like little spinning particles. You hear that? There's a spring on there. That's a particle. It's dark in space. It's black. You don't see it. It's going there somewhere. Now, what happens when it hits the atmosphere that surrounds the Earth? A little dust on there. Well, what happens? It interacts with the molecules. Now, there's going to be all different frequencies coming out here because this thing is just boiling away. It's setting out all these kind of electrons in every single range of frequency, spinning faster and slower and bigger chunks and littler chunks and 2 or 3 particles at a time. I don't know what's spitting out of there. I really don't. But I do know that you have the red, the green, and the blue. We use crystals to create them. This is just making them out of energetic reactions. Now, I would assume this sends every frequency through the entire spectrum. And I'm almost 100% sure it does. Now, what does that mean to our surrounding atmosphere? Well, there's only certain molecules there's certain molecules here around us that protect us from certain frequencies. One of them protects us from microwaves, which is in the 5G range. The atmosphere is supposed to stop that microwave frequency, that distance of frequency, because that exact distance shakes water molecules. It's not just that they say, oh, it's non-ionizing. Well, that may be true, but it shakes water molecules, the H2Os in there, so that they literally boil inside of their own molecule. You know, they vibrate like hell, let's put it that way. And water makes up virtually everything organic. Virtually everything. If you don't have water, you're going to die. No water, you're going to die. So, I think it's a pretty important thing to consider, especially when they're putting these very high, because it's not supposed to allow it, so they have to put them very close and they have to pump them up a little hard to make it force through. I would think insects and bacteria and all kinds of microorganisms are going to have a very difficult time with this radiation. And I think it should be tested a little more seriously than it is. I know it's virtually always a money thing. I can't stop that. That just happens to be the way of the world and the way of human nature. I have witnessed it over and over and over and over, and there's nothing I can do about it. So I can only just present what I am showing, and I'm going to tell you right now, we are scrubbing through the atmosphere, and the harder we scrub, the more energy we absorb, and it doesn't spit out the same way it's getting absorbed. There's a bazillion particles in space. We're scrubbing through them, the sun's scrubbing through them, everything's scrubbing through them. Now, why do I show this frequency? Very, very long frequency here. I don't even know if you can see it. From the moon. Well, the moon is a broadcaster of what it receives. So it receives the light. Now you would say, well, it received the light, and why does it reduce its frequency coming back to Earth? The reason is because it's just like a rubber ball. When it hits it, it's not just a mirror and the exact same light hits that, comes down to here. No, it hits it, it goes boing, and then it comes back here. And the hardest it can hit down here is in the red region. That's why moonlight is moonlight. It's not sunlight. It just doesn't have the same energy. That's all it is. Now, coming from the sun, you could have very slow waves, you could have very fast waves, you could have big chunks, you have small chunks. You've got particles. It's just the way it is. Solar wind, they call it. They got all kind of names, and then they say there's nothing there. It's just unbelievable how hard it is for them to admit, to take a look. Let's just start from the beginning again. They know right now, and I probably showed it in this video. I've shown it so many times. If you look up the Royal Institution, they say, yes, the standard model, the Bohr model, is wrong. There's a new boson been discovered, and lepton universality is wrong. The particles don't equal. My particles work out perfectly. Okay, my friends, I've been saying I'm going to put this video, this website back up. I haven't had it up for 5 years or more. It was up for a very short time. I couldn't deal with it, and I still don't think I'm going to be able to deal with it. I really need somebody to run the thing and handle day to day and so forth. I do the research. I like the research. But I got all of these things, and I've got a bazillion different videos. What I think I'm going to do is just start off by putting a couple up about light and health, because the health is the most important thing right now. It's probiotics and all that business. And I'm being shut down virtually everywhere. I only have a few thousand hits tops on any of my videos, so I need to open this back up. My point is, I am going to open it back up, and I will. It's all done. I just have to put a couple of things on here, and what the features are going to be, and that sort of stuff. And the DNA report is here, and contact information, and all that business. So I guess that's what I'm going to do, is open it back up. So it will be soon. I got to talk to the administrator, who happens to be my wife, and not normally in a good mood at me. So let's see what I can cajole her into doing. Anyway, that's what I want to do. Maybe somebody wants to get involved. I don't know how you do it. I don't know. I really, at this point, I guess I'm just going to drop a few things up here, not a whole lot, because it gets confusing. And I'll try to organize it a little bit, best I can. All right? Thank you. I love you all. God bless you.